can see the screen in front of you with some points written. Yes, Veer, can you show me a thumbs up if you can see? Okay, thanks. Okay, so these are the points which you have to remember when we are studying chemistry in grade 9. The first point says study as per the scope of syllabus. Now, if we have gone through the textbook yesterday, you can see like every chapter begins with scope of syllabus on the top. Okay, now scope of syllabus are the topics, it shows the topics which you have to study from that chapter. There will be a lot of things which will be shared in the chapter, but then you have to study only the ones topics which are mentioned in the scope of syllabus. You can just read through the other topics which are there in the chapter. Okay, so that is the first thing. The second thing is page number 3. You have valency chart. So valency chart we have already studied in grade 8. We are using the same valency chart because we gave you grade 9 valency chart in grade 8. So obviously you are familiar with the valencies and all. Point 3 is you have to practice valencies. You have to know how to write formula, and you have to know how to balance equations. All these 3 things, valencies and all, we have studied from grade 7. Formula and balancing equation we have studied in grade 8, so that also we have done. And when you're writing your answers, whether it is your school exam or your board exam, you will write answers mentioning the keywords. You don't have to write stories. Okay, because we don't get marks for writing stories in chemistry. We write the keywords there and we get the marks. Okay, so it can be very simple. If it is a 1-mark question, even a 1-line answer with the keywords properly mentioned will give you the full marks. Okay, and the most important thing is the last point, that is board evaluation does not have any half marks there. So if your answer is half correct, you still get a 0. Okay, so you have to make sure that your answer is completely correct. So these are the things which you have to remember when we are studying chemistry grade 9. Okay, and by the way, chemistry grade 9 is quite simple. Okay, so you don't have to worry about it because you all studied almost everything. Conditions apply again, that is if you have studied. So okay, so the first chapter we are studying is language of chemistry. So the first topic which is explained in language of chemistry is symbol. So if you have gone through the textbook, you would have seen representation of different elements in the the representation of say oxygen or hydrogen or nitrogen and all. It was they were using actually diagram sort of things. Okay, like they are drawing a circle and they're drawing a circle, they're putting a dot on it, then they are putting lines in the circle and all. That was very primitive way of identifying a substance. So that is how symbol began. So what is a symbol? So symbol is nothing but a short form of an element. Okay, so it's like a very simple way of representing an element. So you already know what a symbol is, and you already know what is the difference between a symbol and a formula is. So we'll come to formula in a while. So symbol may you have to know how do you represent different elements using symbols. So this we have studied in the last year. We take the first alphabet of the name of that particular element and we represent that, and that is the symbol of that particular element. Say for example, carbon is C and hydrogen is H and fluorine is F. Okay, things like that. But then when we have got elements which are starting with the same alphabet, then what we do is we go for the second alphabet or we go for the next alphabet, whichever is there. So that is how we get this helium as He. Okay, so this is the second way of writing the symbol for an element, right? And then we have got the Latin name, Greek name, and all those kind of names. Like say copper is cuprum, so we are taking first two alphabets of cuprum and we get Cu. Sodium is natrium, so that is Na. Potassium is kalium, so that is K. So these are the different types of symbols. That is how we represent elements. Okay, so very simple thing. Okay, so nothing to go into detail about that. We already know this, and we are supposed to know the symbols for at least the first 20 elements because we'll be using that extensively in grade 9 and 10, right? So the next topic which we are studying is valency. The definition of valency is given on the screen, which is the number of hydrogen atoms which can combine with or displace one atom of the element or radical so as to form a compound. Okay, so it is like, if I'm taking an example, it will be very easy for you to understand. So if I'm taking a compound, say HCl, so I have got one chlorine atom over there, and the valency of chlorine atom is 1. So if I'm taking one hydrogen, okay, so it is combining with one atom of chlorine, valency of chlorine is 1 because chlorine is combining with one hydrogen atom only. Okay, similarly, if I'm taking water, you can take like it is one atom of oxygen which is combining with two atoms of hydrogen. So which means that the valency of oxygen will be 2 because hydrogen, number of hydrogen is 2. Similarly, we have got ammonia, wherein we have got one nitrogen and it is combining with three hydrogen atoms. So therefore the valency of nitrogen is 3. So you all know the valencies of these things. You already know that valency of chlorine is -1. Valency of oxygen is -2, valency of nitrogen is -3, which we study as nitride, IDE. Okay, so this is one way of studying valency, that is you look into the formula of that compound and you see the number of hydrogen present in the compound. So in that case, what would be the valency of sulfate if I am giving you H2SO4? So valency of Anshuman, can you tell me the answer? What will be the valency of sulfate in H2SO4?
Uh, two, two.
2. So why it is 2? Because
The two hydrogen atoms.
there are two hydrogen atoms in a molecule or in a compound, like, if I'm taking H2SO4. Okay, good. Okay, so this is very simple. Okay, this is one way to identify valency. The second way is this, we have studied valency chart. So we have seen, like, way better things. So valency of metals, we can find out by finding the number of electrons lost by the metals. So we have already studied that metals lose 1, 2, or 3 electrons from their valence shell so as to become stable. Okay, so in this case, if I'm taking the first example, okay, I'm sorry. You can click pics if you want. You don't have to write down things because all these things are there in the textbook also. There is no need to write down things. Okay, if at all you feel like writing down, you can click a pic and you can, like, you can take a print screen thing which you can do on computer if you are doing it, or you can take a screenshot if you are using a mobile phone. Okay, easy ways to remember stuff. Okay, so valency of metals. So if I'm taking sodium, so atomic number of sodium is 11. So if I'm writing the electronic configuration of sodium, it would be 2, 8, 1. So the valence electrons which we have for sodium is 1. So this one electron will be lost by sodium to become sodium ion. So if I'm taking an example of calcium, the atomic number of calcium is 12. So the electronic configuration of calcium becomes 282. So valence electron is 2. So obviously it will become, like, 28 by losing these 2 electrons to become stable, that is obtaining octet configuration. Therefore the valency of calcium is Ca2+. And the last example given over here, aluminium, atomic number is 13. So obviously the electronic configuration becomes 2, 8, 3. And as a result, aluminium becomes stable by losing these 3 valence electrons, thereby attaining the electronic configuration of the nearest noble gas, which is neon. Hence, we can see that the valency of aluminium is Al3+. Okay, I hope you understood how we are doing valency of metals, right? Then we have valency of non-metal. So non-metal is exactly opposite of that of metal. So in metals, it was losing electrons, and in non-metals, it will be gaining of electrons. So again, examples given to you, fluorine, the first one. So the atomic number of fluorine is 9. So if atomic number is 9, electronic configuration becomes 2, 7. So now as you can see that fluorine has got 7 electrons in the valence shell. it has got two options: either lose 7 electron, achieve duplet configuration, or gain 1 electron and achieve octet configuration. So now it goes for octet configuration. Why? Because it is not possible to lose 7 electrons, because it is like, you have to deal with a great amount of energy to remove that kind of electron. Okay, stop annotating on the screen. You are not supposed to draw anything on the screen. Okay, so it is very easy for fluorine to add 1 electron and become 8, rather than like, losing 7 electron and becoming 2. Okay, as a result, your fluorine atom will accept 1 electron and become 2 8. That is the electronic configuration of neon. Hence it gets a valency of -1. Why minus? Minus is because it is accepting electron, and why -1? Because it is accepting 1 electron to become stable. Is this clear? Veer, is there any doubt? You have raised your hand, so that's why. Okay, no doubts. Good. Okay, so next thing, yeah, calcium. Okay, I made a mistake there. Calcium is 2882. I'm sorry, extremely sorry over there. Calcium is 2882 and not 282. Okay, thank you so much for rectifying that. Okay, so we will move on to the next one, that is oxygen. So oxide you have studied, it is O2 minus. So O2 minus, so it is having a valency of 2 minus. Why? Because oxygen, atomic number of oxygen is 8. So the electronic configuration of oxygen is 2, 6. Now you can see that in the valence shell, you will whoever is drawing this particular thing, kindly refrain. If I see these kind of things happening, your class stops right away. Okay, okay, so please don't play around. Okay, we don't have time for that, right? Okay, we'll play only when I say okay, we can play. Okay, right? So the number of valence electrons is 6. So it needs 2 electrons to become stable. So it will accept 2 electrons to become 2, 8, and that is why it is having a valency of 2 minus. Okay, that is how we get 2 minus valency for oxygen. We go for the last one, that is nitride, that is N3 minus. Nitrogen atomic number is 7. So the electronic configuration of nitrogen becomes 2, 5. Now, if you look at the valence electrons, there are 5 valence electrons, right? So in order to become stable, nitrogen can either lose 5 electron or gain 3 electron. Gaining 3 electron is easier than losing 5 electron. Hence, it gains 3 electrons to become 2, 8. And that is the reason why we have a valency of 3 minus. So you all know that the minus sign stands for the accepting part of the electron, and the number stands for the number of electrons the particular atom has gained. Okay, so valency of hydrogen is 1 plus. Okay, so hydrogen is represented as H plus. Now I hope I have explained it in grade 8 that hydrogen in the periodic table can be found in 2 different places. One is in group 1 along with that is group 1 along with alkali metals, and it is also found in group 17, that is halogens. Okay, so you can find hydrogen in these 2 places. Okay, so that is because hydrogen has a very unique property, that is it is having actually 1 electron in the outermost shell. Okay, so the electronic configuration is 1. So there are 2 things which hydrogen can do. The first thing is that it is lose whatever electron it is having and become H plus, as it is written over here. So when it is losing 1 electron, it gets 1 positive charge, and it is called as hydrogen ion. Okay, another thing what it can do is like it will gain 1 electron, that is it has got 1 electron in the valence shell like this. So it will gain 1 more electron and it will become 2, that is duplet configuration. If it does that, it will have a valency of -1. So in that case, hydrogen will be represented as H -1. Okay, and in this case, the name of this ion which is formed over here will be hydride. Okay, so this is another form of hydrogen. So hydrogen, when it is accepting an electron, it becomes hydride, but mostly like almost 95% of the time, hydrogen has a tendency to lose electrons, and that's the reason why it is predominantly showing all the properties of metals, that is alkali metals, which is like group 1. Okay, so that is this one. Okay, so hydrogen shows the properties of alkali metals rather than like halogens, and that is the reason why hydrogen always like shows valency of +1 instead of -1. Okay, so these are like small things which you have to remember. Then we have monovalent, divalent, trivalent, and tetravalent. So this is just about the number of like electrons which they are gaining or losing or whatever. So if the valency of a particular atom or an ion, it becomes 1, it has got a valency 1, it is called as monovalent. If anything has got a valency of 2, it is called as divalent. If the valency of a substance is 3, it is trivalent. And if the valency is 4, it becomes tetravalent. Okay, so these names, like, just have to know, and examples. It will be given in the textbook. You can refer to the textbook about that. Okay, so the next topic which we have is variable valency. Variable valency also was incorporated in the valency chart which was provided to you in grade 8. So variable valency, it's nothing but the metals which exhibit more than one valency. They are called as like elements having variable valency. Now there are examples of non-metals also. Like we had a question in our grade 8 term 2 paper, like examples of two elements which shows variable valency, which are non-metals. So answer were like sulfur, right? So basically we'll be studying variable valency mostly for metals, because those are the ones who like form like a lot of bonds with non-metals. So that's why we are just sticking to metals over here. So there are two examples given to you which you can see on screen. The first one is iron, which is like Fe2 plus and Fe3 plus. So Fe2 plus, okay, Fe2 plus. So Arya Thakur, can you tell me what do you call Fe2 plus? What is the name of that ion?
Ferrous.
Ferrous. And what is Fe3 plus?
Ferric.
So what is Cu2 plus?
Q.
Q. And what is Cu1 plus?
Q press.
Okay, so that's it. Okay, quite simple. So we already studied that, right? So this is all about variable valency. Then we have the next topic, which is radicals. So radicals is group of atoms of elements that behaves like a single unit and shows a valency. So the example which we have taken, you can see on screen, is ammonium ion. Now we have studied that in grade 8. This is the only like positive ion which is made up of non-metals. Otherwise all positive ions are metals. So this is the only non-metallic thing which has got a positive valency, right? Then we have hydroxide ion, and then we have phosphate ion. Okay, so what is radical? Radical, unlike like the valencies or like the ions which are formed, they are having more than one atom present in it. So if you see ammonium, you have got an atom of nitrogen, and you can see that there are 4 atoms of hydrogen. Similarly, if you look into hydroxide, you can see there are like there is 1 atom of oxygen, and then we have 1 atom of hydrogen. Okay, then we have phosphate, where we have 1 atom of phosphorus and 4 atoms of oxygen. If I'm just representing an ion, it would be like like F minus. So this is, you can see that there is only 1 atom over here. So that is what is generally called as ion. Okay, so that is a difference between a radical and an ion. So you need to know the difference. Okay, this again we have studied in grade 8. Okay, the next one is chemical formula. So chemical formula is a representation of a molecule, of an element, or a compound. So chemical formula can be used to represent an element and a compound. Now what is the difference between like formula? Now we generally tend to believe like if I'm taking an element, it should be like symbol, like hydrogen is H. So what is this H2? So H2 is nothing but the stable form of hydrogen. That is hydrogen, you know that it is a diatomic substance, so it cannot exist in the form of a like single atom. So it combines with another atom of hydrogen to form a molecule of hydrogen. So the element hydrogen in its stable state exists as H2. Similarly, nitrogen also exists as N2. Like that, we have got like many examples like oxygen, okay, fluorine, chlorine, all these things, they exist as like, diatomic substances. So this is a formula which is used to represent diatomic or triatomic, okay, those kind of elements, right? And then we have a compound. Now compound, we have like, as we studied, like, it's a combination of one or more elements. So the examples as I've shown on screen, methane is given, calcium oxide is given. You can see it is a combination of atoms coming together and forming bonds and existing in a stable form. So when we are representing compounds or the molecular form of elements, we call it as a chemical formula. Okay, so this also you have studied in grade 8. And compounds, you don't have to learn any definition or anything for compounds. You have to name, you have to study the name and formula of the compounds which are present on page number 5, and that would be basically acids, bases, salts and all. Apart from that, there are a lot of things like hydrocarbons and stuff on the page, so you don't have to study that. You just stick to acid, bases and salts. Okay, so these are the things which you have to remember, okay, in this particular thing. Okay, compounds. Okay, now how to write a formula. You already know how to write formulas and stuff. Okay, so how to write a formula, for those who don't know how to write a formula, I'll give you 2-3 examples so that you can understand how to do it, and then I'll give you particular questions or some questions for you, and that you can write down on a paper and share the answers. I'll call out names and you will give me the answers for that. Okay, so magnesium hydroxide, uh, the first point what you will do is you will write the symbol or the formula which is involved there. So magnesium is represented by Mg and hydroxide is represented as OH. So you'll write down that first, then you will put the valencies of those things. So valency of magnesium is 2 plus and valency of hydroxide is 1 minus. The next step would be to interchange the valencies, which means that valency of hydroxide goes below magnesium and valency of magnesium goes below hydroxide. And we only take the numbers, we don't take the signs, we don't need the plus or minus thing, we just need the numbers. Right, so hydroxide has got -1, so I'll write 1 below magnesium, that is the valency of hydroxide, and I'll write 2 below OH, that is the valency of magnesium. Okay, now why do I put a bracket over here? Because OH is a radical. So this I have taught you in grade 8. Okay, so you have studied that. Again, conditions apply. If you have studied that, you will remember that. We have studied that whenever you're writing a radical, you have to make sure that you're putting in a bracket so that whatever valencies are present over there. Now in this case it is quite fine, but if you have a sulfate or something, you will have SO4 already here, and then if you bring this 2 down there, it becomes SO42, right? So that should not happen. So that's the reason why we should be putting radicals in a bracket. So you put a radical in a bracket and then you put the number outside the bracket. Okay, and the last step is, if the number is 1, we generally don't represent that number, okay, anywhere in the formula. So we just write it as Mg and OH twice remains as it is. So we read it as MgOH twice and not MgOH2. Okay, so MgOH twice, which is magnesium hydroxide. Okay, so I hope you understood this, right? So the next example which you're taking is calcium oxide. In this case, again, first I will write the symbol of calcium Ca, then I'll write the symbol of oxygen, which is O. Okay, then I'll write the valencies. Calcium has valency 2 plus, oxide has valency 2 minus, and then I'll interchange the valencies again without the signs. So 2 goes here from oxide and 2 goes here from calcium. And since both the numbers are the same, they get cancelled off and the formula becomes CaO, okay, calcium oxide, right? And the last example is of ammonium phosphide. Now in this case, see here we studied an example with 1 ion and 1 radical. Here we studied an example of 2 ions, and here we'll study an example which contains 2 radicals, okay? So first thing, ammonium represented as NH4, so I'll write that. Phosphite is represented as PO3, so I'll write that. Then I'll put the valencies of these things. Valency of ammonium is 1 plus, valency of phosphite is 3 minus. interchanging valencies, but before I interchange, since both are radicals, I'll be putting them in brackets. So NH4 in a bracket followed by 3, then PO3 in a bracket followed by 1. Now, as I already told you, we don't have to write 1 because it is understood that if you don't write anything, it is 1, right? So we remove that 1. So when this 1 is gone, then there is nothing outside the bracket. So if there is nothing outside the bracket, do you think we have to keep the bracket there? No. So what do? We remove the bracket. So this bracket is gone, and then we just bring them closer, and then the formula of ammonium phosphide becomes NH4 thrice PO3. Okay. So this is how you write the formula. Okay. So I hope this is clear. Any doubts? If you have any doubts, you will raise your hand. I'll clarify your doubts. If you have no doubts, just show a thumbs up. Okay, okay, okay. Obviously, Arya Gupta, yes. What is your doubt, Arya Gupta?
Yes. So what's the difference between like a monoatomic molecule and like the compound like CH4 molecule? Like what's the
Monoatomic
difference?
molecule,
The
what does
difference
that
between
mean?
that? Like sir, in the textbook you yesterday you gave the notes, right? So like there was like H2, so that's a molecule of hydrogen.
Yes.
So CH4 is a molecule or like it's a molecule of methane? Like
It's a molecule, it is a compound, and it is one molecule of that compound. If you put 2 CH4, that becomes 2 molecules of CH4.
okay, so
Understood?
that CH4 is basically a molecule as well.
Yeah, it is a compound and it is obviously a molecule. Yes. Okay, so CH4 is a compound. Okay, so if I'm taking just one CH4, we studied as one molecule of CH4. And if we put a number in front of CH4, if I say if it is like 4 CH4 or 5 CH4, that automatically becomes 4 molecules of CH4. And what is CH4?
A CH is methane.
Methane. Okay, that's it. Okay.
And so one more thing, like for the atom, so
Hmm.
here you're telling that like example beryllium has 2, 2, 2, 2, 2,
Hmm.
so will it like lose that 2 to become like a
It will do
like
whatever is easy
duplet?
for it. It will do whatever is easy for it. If losing an electron is easy for it, it will lose electron. If gaining of electron is easy for it, it will gain electron. Okay. So if it is having like say the valence electrons of a particular element, if it is like more than 4, so that is basically 5, 6, 7, it will tend to accept electron. And if it is less than 4, it will tend to lose electron. Okay. That's why metals
What
lose
about
electron.
carbon?
Carbon is group 14. It has got 4 electrons in the valence shell. So it basically, the energy required to gain or lose electrons is